Alright, so let's understand the moment of a force through an example. So we have to find the tension in this bolt, which is supporting a combined load of 1 kilonewton from this tractor seat. So first things first, we need to establish that this whole setup is in equilibrium, which means that the sum of forces and sum of all moments would be equal to 0, right? We will be solving this equation through moments of forces, right? So the first step would be to choose an adequate pivot point. We have three options here to choose from. That is the 3 points of application of forces. We can name them A, B, and C. Now the thing about choosing a pivot point is that the moment of forces applied on the pivot itself is 0, since the perpendicular distance is 0. So for instance, if I were to choose the pivot point A, our moment equation would have two unknowns. One would be the reaction force at B, and second would be the tension force from the bolt. Or if we were to choose the pivot point C, we would be excluding the tension force in our moment equation. So the most logical choice would be choosing pivot point B. Since sum of moments is equal to 0, that means clockwise moments must equal counterclockwise moments, right? From the figure, we can see that the 1000 Newton force creates a moment in the counterclockwise direction about the pivot P, whereas the tension in the bolt creates a moment in the clockwise direction. So let's find the clockwise moment first by drawing the line of action of force following step 2. Here we can see that the perpendicular distance is pretty obvious, and it's already given to us 100 millimeter. So the left hand side of the equation becomes T multiplied by 0.1. For the 1000 Newton force, let's extend the line of action of force once again. Here, a number of students mistakenly use 300 millimeter as the perpendicular distance, which we can see very clearly is not perpendicular to the line of action of force. However, the perpendicular distance can be found pretty easily by simply multiplying cos of 60 with 0.3. So the right hand side of the equation becomes 1000 multiplied by 0.3 times cos of 60. From there on, solving for T, we get the tension in the bolt to be 1500 Newton. And that's it.